Hello friends, this is another lecture of linear homogeneous partial differential equation method to find particular integral pi. In previous two lectures, we studied case first and case 2. Case first was when R.H.S is of the form e raised to power ax plus by. Case second was when R.H.S is of the form sin ax plus by or cos ax plus by. Now we are moving on to case number third, when R.H.S is of the form phi ax plus by, or we can say this is a general form because any kind of function may exist. It may be exponential, it may be trigonometric, it may be logarithmic, it may be any other kind of function, algebraic function. Then pi of 1 upon f d dash phi ax plus by equals to 1 upon f ab integral up to n time phi u du up to n time, where u equals to this particular ax plus by, and same providing fab not equals to 0. If fab equals to 0, then apply the previous condition, pi is equals to x into 1 upon f dash ab integral up to n time phi u du up to n time. And if again this f dash ab equals to 0, then again multiply by x and differentiate denominator with respect to d, then put d equals to a and d dash equals to b. For better understanding, we shall solve some question based on this particular method. Now this is the first question. Solve del 2 z over del x square over del 2 z over del x del y minus 6 del 2 z over del y square is equals to x plus y. For the solution of this type of problem, we shall start from putting del over del x equals to capital D, del over del y equals to capital D dash. So d square plus d dash minus 6 d dash square z equals to x plus y. For auxiliary equation, putting d equals to m and d dash equals to 1, then equate to 0 the bracket of LHS. So what do we get? M square plus m minus 6 equals to 0. This is a quadratic equation, so we can solve it. After solving, we get two roots, 2 and minus 3. So CF for the partial differential equation is f1 y plus 2x plus f2 y minus 3x. Now pi of 1 upon d square plus d dash minus 6 d dash square x plus y. Here we have a equals to 1 and b is also equals to 1, and the degree of this particular term is equals to 2. So we shall integrate it 2 times. Okay, first we have to put a equals to 1 and b equals to 1. Identify whether it is 0 or non-zero. When we put ab equals to 1, 1 plus 1 minus 6, it will become minus 4. So it is a non-zero quantity. So we can proceed further. That is 1 upon 1 square plus 1 into 1 minus 6 into 1 square. Double integral based on this degree. Double integral, and this entire function will convert into u du d. Okay, so this is equals to 1 upon minus 4. First time integration of u is u square by 2 du. Again integrate it, minus 1 upon 4 u cube by 6, or we can write it as minus u cube by 24, or pi is equals to, what is the value of u? X plus y. So pi is equals to minus 1 upon 24 x plus y whole cube. So gs is equals to cf plus pi, or z equals to f1 y plus 2x plus f2 y minus 3x minus 1 upon 24 x plus y whole cube. Answer. This is the answer of this type of problem. Now we will take another problem. Now this is the second question. Solve 4d square minus 4d d dash plus 4 d dash square z equals to 16 log x plus 2y. So for auxiliary equation, putting d equals to m and d dash equals to 1, then equate to 0 the bracket of LHS. 4m square minus 4m plus 1 equals to 0. I think this is 2m minus 1 whole square. So we get m equals to 1 by 2, 1 by 2. So equal roots exist. Equal roots exist. So CF is equals to f1 y plus x by 2 plus x f2 y plus x by 2. Now pi of 1 upon 4d square minus 4d d dash plus d dash square 16 log x plus 2y equals to 16 is a constant. Take it into the left side of this particular term. Now check from this a equals to 1 and b equals to 2. So check whether it is equals to 0 or not equals to 0. When we put t equals to 1, this is used for d equals to and this is used for d dash equals to. So when we put d equals to 1 and d dash equals to 2, it will become 0. We have to multiply by x and differentiate this with respect to d. So 8d minus 4d dash log x plus 2y. Now what to do? Again put d equals to 1 and d dash equals to 2 and it will become 0. So again multiply by x and differentiate it with respect to d, and this function remains as it is, log x plus 2y. So d eliminated, we get pi. On simplifying it, we get pi equals to 2x square log x plus 2y. Hence gs is equals to cf plus pi, or z equals to f1 y plus x by 2 plus x f2 y plus x by 2 plus 2x square log x plus 2y. If you like this video, then like and subscribe my channel. Thank you.